In this video, we look at two examples from probability. So the first example, we're going to check to see which are valid probability distributions. So over here on the left side, we've got the list of what we're going to check. We're going to verify that all the probabilities add to 1. Probability values need to be between 0 and 1. It doesn't make sense to have a negative probability, and it doesn't make sense to have a probability more than 1. And we're going to verify there's no negative values. So each row corresponds with a different possible grade distribution of grades A through F. So these are proposed grade distributions for some classes. So row A has all positive values. So our next step is to check to make sure that the sum is 1 or not. So over here on the right side, we are going to add it up. So I put that symbol sigma capital sigma, like you see in Excel when you sum or add it up. It's just math notation for summing something up. So if we add up the 0.3, 0.3, 0.3, 0.2, and 0.1 for grades A through F, for choice A over here, the sum is 1.2. So that is not a valid probability distribution. Choice B in the second row has no students getting A's, no students getting B's, all students getting C's, and no students getting D's or F's. So you wouldn't necessarily want to be in this class, but the sum is 1, all values are between 0 and 1, and there's no negatives. So row B is actually a valid probability distribution. In row C, in that class, no students get D's or F's, and 0.3 is the probability for getting A, B, or C grades, so that's like 30% of the students get A's, B's, and C's. So that total is 0.9, or you could think about it as 90%. So row C is not a valid probability distribution because the sum is below 1. So we're missing some part of the class there. Row D, we see over for F grades there's a negative probability. It doesn't make sense to have a negative probability. So even though in row D the sum is 1, when we add up the 0.3, 0.5, 0.2, 0.1, and negative 0.1, because we've got a negative in there, it's not a valid probability distribution. You'd never have a negative chance of getting an F grade. The lowest possible chance of something is 0. Row E has 0.2 for A grades, 0.4 for B grades as a probability, 0.2 for C grades, and 0.1 and 0.1 for D and F grades. So in that class, the most common grade is a B. And those all sum to 1. All the probability values are between 0 and 1. No negatives. So row E is also a valid probability distribution. When we look at row F, even though the sum is 1, the problem is that we have negative 0.1 for B grades. And again, you'd never have a negative chance of getting a B. And then C grades are over 1. So both of those make this an invalid probability distribution. So in review, when we look through these possible grade distributions, only rows B and E are valid probability distributions meeting the criteria that the sum is 1 and the values are 0 to 1. The next example, and the numbers for these examples don't necessarily mean anything, the 5 and the 6. They're from an old handout I had. So in example 6, we're applying the multiplication rule. So here in part A, we want to look at the expected number of smokers. So we're assuming at this university 13% of students smoke. So we'd say the probability of smoking is 0.13 in decimal form. So part A asks us to calculate the expected number of smokers in a random sample of 100 students from this university. Our calculation to find the expected number is to take the number of students and multiply it by the probability of smoking. We often say in shorthand, the expected number is n times p. And sometimes we describe this as the mean or the center of the distribution. So 100 students times 0.13 gives us 13 expected smokers at this university if it's a random sample of 100 students. Notice the importance of this being a random sample. The students have to represent everyone on the campus for this n times p probability calculation to work. So this is an application of being able to multiply the number times the probability. So we're able to multiply here to solve. Now part B says, what about 27 students gathered outside the gym at 8:55 on a Saturday morning? Can we use these students and calculate the expected number of these students who are smokers? And so these are not a random sample. So we want to note that these 27 students are not a random sample. So our calculation, the multiplication rule, does not apply. For the multiplication rule to apply, we have to assume it's a random sample and that people are independent. They're not family members or related in any way. So we expect that students at the gym probably smoke less than all students at the university since they are health conscious. So they're not going to represent a random sample of students at the campus. So these problems should help you in solving your Chapter 3 lab assignment. You've got some similar problems where you're applying multiplication, and in one problem you're checking to make sure something is a probability distribution.